so first thing first then, we take an alkane, and remember we talked about alkanes being, let's switch color pens. We talked about an alkane being however many carbons you have, say 4, alright, there must be how many hydrogens? There must be 10, okay? Because if you do that, what you're looking at is however you arrange these 4 carbons, there must be 10 hydrogens to complete the molecule, okay? So alkanes, the whole molecules, are they compounds, okay? Now, in order to get a group out of it, what's the point of getting a group out of it is, if you want this molecule, the whole idea is with organic structures, as they get bigger, as you get more and more complicated molecules, essentially you're just taking smaller fragments and combining them in a bond-making reaction, for example, or a bond exchange reaction, yeah? So the idea of parts of molecules, we call them groups, functional groups, okay, alkyl groups, etc. And the first thing we're going to look at is alkyl groups. Now, here is propane, okay? So with propane, it's a complete molecule, but if I want propane to be attached to this group, yeah, I have to attach it. It means I have to remove one of the hydrogens. It's as simple as that. So this becomes a bonding possibility. That's why alkyl groups are important. All right? And generically, because we have to remove one hydrogen, okay, and of course I can break one of these bonds. But if I do, it's no longer propane. Yeah? Okay, so I don't want to damage the molecule too much. I just want to open one point so I can then attach it to a bigger molecule. All right, so that makes it an alkyl group. So therefore, the formula must be one less. So here I can say erase this hydrogen, or I can keep that hydrogen, and how do I do undo? Oh well, keep that hydrogen back there and say erase this one. You see what I'm saying? Okay, so that's what alkyl groups are. I want to take you through these very quickly. I'm assuming you've read this. Okay, so look at the structure. Look, in methane, I'm going to have to pause this because. All right. So you take an alkane, you cross off the ane, and you put in YL, and that becomes an alkyl group. Easy, isn't it? Right? So when we look at, and they didn't do C2, that's annoying. Okay, let's look at a C2 then. I'm going to jump down, so just I've got some blank space. Okay, so if I were to take ethane, which is C2H6, all right, ethane becomes, you've just said it, an ethyl group, correct? All right, and what's the formula going to be? C2H5. Okay, so every time you see C2H5, you know it's an ethyl group. Okay, now ethane, tell me whether on paper it's okay or do I need to do models, okay? If after a while you go, I want to see the models, great, but it won't be recorded, all right? So here you have an ethane molecule. Now, you've got 6 hydrogens there. How many different ethyl groups can I get out of it? Would it be different if I remove this hydrogen than this hydrogen? Okay, so let's try it. So would it be different if I were to remove this hydrogen compared to this hydrogen to this hydrogen? Let's try it. Pick it off. And you see that group? Okay, now pick it off. Let's pick off a different one. Believe me, it's a different one, yeah? Okay, but look, it's the same. Make sense? Okay, and of course, if I were to pick off, and this is the other carbon, right? Pick it off here, it's at the top. Okay, do I have a different ethyl group? Okay, it's the same. So it's the idea of equivalence. We're good so far. So ethane gives only one ethyl group. Okay, now let's move ahead. Methane now. Where are we? Now propane. Can you guys see propane? All right. Let me see if this makes sense to you. And please be honest and say, can you go over that again, please? Okay. Now let's look at propane. Propane is C3, so H, how many? 8. So therefore, to get a propyl group, I hate you. Behave. Behave, or else I'm donating you. We will talk later. So there's propane. And we have 8 hydrogens there. How many different propyl groups can I have? 2. Okay, any more? Any less? Okay. So does it make sense that whether I strip off any of these 6 is going to be the same? Yes or no? Okay. And these 2 are on their own. Make sense? You know what? If it doesn't make sense, okay, wave at me like this or look constipated, and then I know you're in trouble. All right? Okay? Don't worry if it's going to be the nature of a large class. Some of you got it straight away. Some of you just need a little bit more. Okay? Needs a repetition. Anybody okay? Anybody need a bathroom? You're good. Okay. So there's going to be two of them. Okay? And going back up. Okay, you see there's the 2 propyl groups. Do you see it? Propane gives you knocked off one of the end ones, and here it's got one of the middle ones. Does that make sense? Isopropyl. We'll look at the names in a moment, but one is called propyl and the other one's isopropyl, because you've got to distinguish between them. Okay? Now, butane then. Butane, how many different positions do we have now? Do we have 1, 2, or 3 different positions? 3. Are we all okay with that? These end ones are all the same, aren't they? Okay, so the butyl group can either attach this way via the end, all right, and this is the same, or these 2 are equivalent, aren't they? All right, so there are 2 of them. The problem is, apart from my laptop, okay, is that when you have butane, okay, you have this one that gives you 2 butyl groups. Agreed? But for the butane, so that's butane side, and that's the alkyl side. You can also have butane in this arrangement. And in this arrangement, how many unique positions do we have? 1, 2, 3. Okay, and we've got a difference there, yeah? Okay, I hope I've made it. Can you see that this is the carbon in the center? You see the carbon has 3 methyl groups coming out of it, and then it's got this one here. All right, so this one is clearly unique, and these 3, they're the same. All right, so you got 2 more groups there. Okay, and let's see if I can write this one here. You see, I've changed one of these hydrogens to be a group, yeah? So that's 1 butyl. And then going back, we said one of these, yeah? So how about, let's just strip off. You see I stripped off a hydrogen from this carbon here? Okay, so that's where we attach. Does that make sense? Yeah? Yeah. No, there are 2. There are 2 different attachments there. On this one, yeah.
Just 2, not 3.
Yeah. I meant to have said 2. Okay, so you see how these N ones are the same, and then the one in the middle is different, yeah? So we have 2. Okay, so how do they look like? Okay, so what I'll do is keep that hydrogen, but you see this N1 here? Instead of 3, that's where I knocked off the hydrogen. You got me? Okay, and then the other one, I said keep the methyl groups. Okay, but I'm going to knock off that hydrogen there. Make sense? I got 4 groups. I haven't talked about their names yet. I will. Okay. And then I think let's not do the C5s yet, but go through the notes. You see, this time you go back to your notes and you look at these again. Yeah. Yep. Oh, sorry, that should have been a... Oh, no, that's right, that is CH2. So you see that one there? You see I have 2 hydrogens here, but I should have had 3. Yeah? So here you see I've got 10 hydrogens because butane is C4H10, and this one must be C4H9. Make sense? Okay, good. So I'm going to go over these alkyl groups quickly, and I think we've covered them all. And then this idea you'll get very, very quickly now. Okay, you can learn many alkyl groups, but for simplicity, okay, we normally just classify them as primary, secondaries, tertiaries. Now the different butyl groups, the different propyl groups, and the different pentyl groups, you have to know the names. But it's also useful to be able to classify them, and this is the idea, okay? So let's look at this one. Can you see this carbon here, yeah? If I were to remove this hydrogen and attach it to myself, this carbon has 1 carbon attached to it. You got me? This carbon has 1 alkyl group attached to it. We call that a primary. Okay? This carbon here, all right, remove the hydrogen. This carbon here, how many alkyl groups are attached to this one? So it's a tertiary. It's as simple as that, isn't it? All right? Yeah. I like it when people say that. All right? So, and you can read it. Let's look at this one then. Just to make sure, if you haven't already done it, and I've lost things already. Okay? You see how this, okay, and they switched it now. You see this carbon here, all right? Look at how many alkyl groups is attached to it. It's a very complicated alkyl group, isn't it? But how many alkyl groups is attached to it? Just all of this here, agree? Just through that bond there. Are we okay? And therefore, we can call these primary hydrogens because they're found on a primary carbon. All right? And you see why this carbon, primary or secondary. How many alkyl groups? Yeah? So there's the one group is an alkyl, and then there's this group on this side, yeah? So those are secondary hydrogens. Easy? Okay. Now let's make sense of those names. The names are not always systematic. Okay? Yep. Are we okay? Yeah? Okay. So when we have methane going to a methyl group, hey, let's call it methyl. When we have ethane and it becomes an ethyl group, let's call it ethyl. Yeah? When we have propane, okay, there are now 2 of them. All right? We have this one. Agreed? And we have this one. Okay. Now, for the smaller alkyl groups, the names are not fully systematic, so you have to learn them. Okay? Now, which one would you say, if N stands for normal, which one would you call normal propyl? N-propyl? The straight one, yeah? Because that's always a good point of reference. So that's N-propyl, okay? And the other one, we call it isopropyl, right? Iso, the root is, it means geminal dimethyl. It means that carbon has 2 methyl groups coming off it. Okay? Now, it'll become more familiar when you look at the C10H, C4H10 series. And I wrote these up already, okay? So where were they? They were here, remember? Okay? There are several names. Of the 4, one is called N-butyl. Which one do you want to call that one? Yeah, so there's your N-butyl. All right? One of them, yeah, is called sec-butyl. Which one looks like a sec-butyl? We've got 3 left. We've got this one left, and this one. It's going to be the second one, isn't it? Yeah, okay. That's sec-butyl. All right, and the other 2 is called isobutyl and tert-butyl. All right? Which one's the tert-butyl? Which one's the tertiary butyl group? This one or this one, yeah? It's got to be the bottom one, not the third one. It's got to be this one, the 4th one. Is that what you mean? Exactly. It's got 3 alkyl groups. Okay, so it's tertiary. The names are making sense, aren't they? All right, so this one's the tert-butyl. And this one, what did I say iso means? Look, it actually got these 2 geminal dimethyl groups, but be careful, because this is the carbon of interest, but it's got that geminal dimethyl group. That's why I said the names are not fully systematic, but this is a good way to remember the 4 butyl groups. All right? There's a video that goes through this again. Please watch it. It's only about 5 minutes, but it walks you through exactly what I've done. Yeah?
So even though that carbon, the CH2 on the end, is the one of interest, so it technically only has one methyl group attached to it. It's still iso, meaning 2 methyl groups?
Iso normally just a lot of compounds with geminal dimethyl groups picks up the name iso.
Even though it's not attached to the...
Yeah. Because before we have learned to name compounds systematically, they had a lot of compounds, and geminal dimethyl groups are very common in nature. And they end up just picking up the name iso.
So is it fair to say if you see that arrangement, even though it's not attached to the main carbon, it's still considered an iso?
You're going to hate me for this, but remember I said naming these simple groups are not systematic. So you learn it, but its usefulness runs out quickly. It's much better off looking at how to name things systematically. Okay? Hate me? Thank you. Okay. Are we good? Okay. So hopefully that will allow you to go and engage with the homework. I'm slightly running out of time because I want to cover nomenclature. But let's see. So we looked at the different groups. Okay, and luckily there's no... This is the nomenclature. Okay. Okay. And I think you'll be fine, you know, draw the 8,5 carbon alkyl groups. Yeah, I think you'll be fine on these. After we looked at alkyl groups, etc. Show of hands who really, really, really needs me to do this. But remember, if you really, really need me to do this, I'm going to go over nomenclature really quickly. Good. I'm manipulative, aren't I? I think it's more that I trust that you'll be able to do the homework well. All right? Naming. Okay? We can read it. I've assumed you've read it. Okay? But let's just try something. All right? Let's just try something. What's this compound? What's this compound? Butane, because it's got 4 in a row. All right? What's this compound? Methane. Okay, let me put methane on the end. And what does it become? Yeah. Somebody said 1-methylbutane. Yeah, kind of makes sense, doesn't it? There's butane. On carbon number 1, there's a methyl group. You got me? There's the butane attached to a methyl group. But it's much more logical to say, no, there are 5 carbons in a row, so it's pentane. You got me? All right, so now then, let's put that methyl group. I can't, you can roll with this. What if I were to put it here? What does it become? No, don't give me 1-methylbutane. What is it? Pentane. Because in naming a hydrocarbon, go for the longest chain. Now the problem becomes, everybody okay? If you're not okay, just wave at me. Hi. Okay. Demo this. Right. So here, to go backwards to get the name, do this with me because you can. Hexane is how many? 6. So let's put 6 in a row. Okay. And what do we have at carbon number 3? We have an isopropyl. So the isopropyl is this way. You see? There's your isopropyl. Yeah, okay? And then what else do we have? At carbon number 2, we have a methyl group. Okay? Right? I like doing these naming ones, so let's go and look up a bit more. This is one of your homework one. Okay? Let's do this one. So what's the parent? What's the longest chain? Hept, so that's 7. Okay? Close. Hex is 6 is hex. Okay? So hept, so that's 7. And what do we have here? Carbon number 3, I have an ethyl group. Okay? And then what happens here? On carbon number 4, what do we have on carbon number 4? 2 methyl groups. Alright? Okay. The way to get nomenclature is just do a whole bunch of them. Practice. That's why the homework is all about practicing. Alright? Do you want me to do some more? We can have 2 more minutes to try a couple more. You want to try a couple more? Yeah? Okay. Well, why don't you try this one for me then? Let's do 2 of them, okay? Since I've got it on this page. Okay? Yeah. Draw me C. Go fairly fast. Octane, how many? 8, okay? And what does this part tell me? 2 methyl groups on carbon number 2. So I tend to put 1 up and 1 down. Okay? And what does the next bit tell me? 1 on 4, and there's a propyl group. Okay? I just curved it to avoid this bit. We okay? Alright? I think you're good. I think if you do the homework, you're good. Now, come on. Come on. I just want to point something out to you. Okay? Please, on these videos, yeah, please look through the alkyl groups. I looked at it and somebody mentioned line drawings. The book doesn't tell you enough about skeletals, which is what I call bond line drawing. Alright, and then they immediately begin to use it in the homework. At this weekend, okay, by Saturday 9 o'clock at night, I'll put up a little video on how to do them. If I haven't, somebody bug me, okay? It'll just be a 5-minute little video talking about how to go from writing everything out to skeletals. One last thing. Next week, okay, when you come to lab, if I go online and I found you haven't looked at my videos, okay, You're not doing lab that day. You're going to have to come in and make it up another day, okay? So watch the videos. That's a threat. Okay, good. Go, go, go. The weekend started.